right, welcome to day 55. This is the lesson 6.3a, the first day of exponent laws, which should be review. And then we'll have another day which will feel like new stuff, but it's all based on these basic exponent rules. And it says in the 3-minute review here, this is review, which means old stuff. Evaluate expressions involving its exponents, and we're starting off real slow here. Use a calculator only if necessary. Hopefully, this first part you can do without. -4 squared means -4 times itself, right? -4 times -4 is positive 16. Negative times a negative is a positive. But for B, isn't it the same question? Well, no, it's not, because the negative is by itself, and it's the base to the exponent 2, right? The base here is 4. The exponent 2 is acting only on the 4. So this is the negative of whatever 4 squared is. They're different, and you need to sort of sort that out on your calculator. Now, what happens if the negative is in the exponent? What does that mean? Well, remember, and we'll get to exponent laws in just a little bit, negative exponent means to flip the base. The base is 4, flip the base, now you've got a positive exponent. Okay, so the negative exponent meant 1 over, and then we could calculate. What about 3/4 to the exponent 3? Well, you might be tempted to reach for that calculator, but please don't. I don't think you have to. This means this, right? Means 3/4 times 3/4 times 3/4. Well, you might say I can't do that. Well, look on the top here. How do we multiply fractions? We just multiply along the top. 3 times 3 times 3. That's 3 cubed. On the bottom, 4 times 4 times 4. That's 4 cubed. And in fact, that's often the easier way to think of this, is that this exponent is applied to both of the numerator and the denominator. This is 27 over 4 cubed. You might have to reach for a calculator. I suppose that's okay. It's 64 though. Negative exponent, we said over here, negative exponent means flipping the base. And so we're going to flip the base and have a positive exponent. This time when we flip the base, the bottom becomes the top, top becomes the bottom, no worries. Now, 4/3 times 4/3, or 4 squared over 3 squared, 16 over 9. Decimal's bad in this, folks. Perfect answer is good. Showing your steps and working down the page, that's what we want to see, and so we're not just pounding stuff into the calculator. Except for when we're just pounding stuff into the calculator, like this one. This one means 0.45 times 0.45 times 0.45 times 0.45, and there's no easy way to do that. It's a big long mess. So we put that into our calculator, and we get about 0.041. We use either this button on the graphing calculator, or some calculators have that as their exponent button, or we have that button. We talked about exponents in the last video, or a couple of videos ago maybe. This is one of those 3-minute reviews where it might make sense to do some of the homework now before the rest of the video, but I will leave that up to you. I'm going to go on. Exponent laws. Use exponent laws to simplify expressions involving exponents. Well, this is all review. This is review of the last few years that you've done exponents, and you just kind of have to remember, when we multiply 2 powers with the same base, what do we do to the exponents? Well, we add the exponents. Well, why? Well, you learned this in previous grades, but I'll explain this one, and then I'll just remind you of all of the rest of them, okay? So a to the m times a to the n is kind of like, if we had an example, let's think of x to the 5th times x squared. What does x to the 5th mean? It means x times x times x times x times x. And then a multiply. I'm going to write that as a big dot there, just so we can see big dot means multiply, okay? and then x squared means x times x. Now, how many x's do we have altogether? Well, x times x times x, 7 x's, right? So that's x to the exponent 7. And this example illustrates why we can just add the exponents. And that's the rule. So hopefully you remember that. When we divide two powers with the same base, we subtract the exponents. When we have powers of powers, or exponents on top of exponents, well, we multiply the exponents. So m times n. If you want to put a little times sign instead of just writing mn, I'm good with that. A to the exponent 0, anything to the exponent 0 is 1. Okay, so that's, you just got to remember that fact. You could put it into your calculator, but again, we're kind of anti-calculator for the most part. That's something that you can do in your head. The negative exponent, we talked about it. Negative exponent means flip the base. And so flip the base means it goes into the bottom. It's a fraction like one of those other ones. Well, bottom becomes top, top becomes bottom, and we still flip the base. And then the exponent becomes positive, okay? Notice on the top here, it's kind of like we had a 1 to the exponent n, but 1 to the exponent n is just 1 anyway. Any more? No more? Okay, well, let's get on to some examples then. It says, simplify, evaluate when is possible. This part here always means for us to do an exponent rule first, okay? We don't want to pound stuff into our calculator until it's necessary, all right? So here, we've got an exponent on an exponent, right? We see that exponent on an exponent, so that's 3 to the exponent negative 6. The negative means for us to have a fraction, 1 over. Flip the base is how I say it, flip the base, and it becomes a positive exponent. Now 3 to the exponent 6 is kind of tough to do. This is the spot where, yeah, okay, if you need to, go ahead and reach for your calculator, all right? But some people might be, I don't know, might be able to do 3 to the exponent 6 in their head. I don't know. Can you do 9 times 9 times 9? That's 81 there, right? Because that's 9 times 9, and then times another 9. Well, can you do that in your head? 9 times 80 is 720, times 1 times 9 is 9. This is 729. Again, calculator's okay for that step. The earlier steps, not so much. Here, again, negative exponent means flip the base. No, hang on. I got two powers with the same base. What do? I add the exponents, right? So I go 4/5, and then the exponent is negative 3 plus 5, integers. No problem. 2. And so now I've got 4/5 times 4/5. You could think of it as that, like that fraction question, which is 16 over 25. Or you could think of it as 4 squared. This is the second way to think of it. 4 squared over 5 squared, 16 over 25. And they're the same thing. I realize that, but it doesn't matter the way that you evaluate it. Look, no calc. No calc here. No calculator needed for that one. This one neither. Okay? Two powers the same base. I'm dividing. I'm going to subtract the exponents. This exponent is negative 3, subtract negative 2. Well, that's maybe hard. I don't know. When we do negative 3, subtract negative 2, when we see the two negatives like this, that's like adding, subtracting, integers adding. So it's negative, loss of 3, gain of 2. Loss of 3, gain of 2 is negative 8 to the exponent, negative 1, right? Lose 3, gain 2, and then negative exponent means 1 over negative 8. We usually don't write fractions with negatives in the bottom, either on the top or out front like that. That's the best way. I probably wouldn't mark that one wrong. And there's sometimes when we have like algebra, it looks like algebra in here instead of numbers, and don't get fraidy cats on me here. The just still the exponent rules, except for we won't have the last step of having to evaluate stuff. So exponents on exponents, x to the exponent. When I have exponents on exponents, I multiply, right? That's not adding exponents. Don't get it mixed up with that question. That's not what we're doing. Exponents on exponents. Here, I'm going to take it slow, but the center dot means multiply, so I'm going to add those exponents. 3 plus -1. Again, anytime I see the two signs in the middle there, I always like picking which one. And when there's a positive and a negative, that's a minus, right? 3 and -1 is 2. 3 and -1 is 2. And I'm going to write down this piece. This is on the bottom. Anything divided by itself is just 1, but if we use the exponent laws, dividing two exponents with the same base, I subtract. 2 subtract 2 is 0. Well, anything to the exponent 0 is 1. I'm left with x to the exponent -10. Usually we don't like having these answers with negative exponents, and most often you'll see in the back of the book they'll write it as a power with a positive exponent, and the positive exponent is in the denominator. So this is the best. Probably I wouldn't mark that wrong. Notice that in the homework today we're going to spend about maybe about 10 minutes or so doing this activity, and it's a little bit of fun and it's a bit silly, but we'll have about 10 minutes to do this activity. If you remind me, we'll pull the MAP4Cers in with us, so they don't get too many activities. There's not enough room for activities in their class, so hopefully we'll remember to invite them. And then there's the homework, all the homework, including that stuff that's like the 3-minute review. All right, that's it for the first day of exponent laws.